So let's look at a more interesting area problem here. We want to find the area inside the limicon r equals 2 plus cos theta. So that's this guy here, the dark graph. And so it's inside r equals 2 plus cos theta, and outside the circle r equals 5/2. So that's here. So inside the limicon, but outside the circle, that's going to be this little crescent sliver. So the area we want to find is right there. And it looks like we've got some symmetry, so find the top area and double it, and that'll give us the bottom area. So first we want to figure out where, let our segment sweep over here and find out where we want to go from. So let's see. So here's our radial segment, general radial segment, and we put it out there, and it's going to sweep from down here up to here. Well, those are the same angle, plus or minus, so we're going to go from 0 up to here, let it sweep over the region. So it's going to trace out that yellow region there, upper portion of the crescent. So that segment there, that's our starting angle, that's 0. And then your ending angle, as this guy sweeps over the region, is that one right there. So that's the curve of intersection of those guys. And then we're going to find this area and double it. So, well, let's write the expression for this area. Well, when we draw a general radial segment there, we've actually got two endpoints, an outer endpoint and an inner endpoint. So if we want to find the area between things, then we have to use a new formula here. So this is area between is going to be an integral from alpha to beta, starting to ending angle. And instead of 1/2 r squared d theta, it's 1/2 r outer squared minus 1/2 r inner squared d theta. So basically what you're doing is finding the area out to and including that crescent, and then taking out the area of the circle, and that leaves the crescent. So using this formula then, we are going to be, so now we need to find that angle. Let's go ahead and find that angle. Well, that angle is on the intersection of these two curves. So we set them equal to each other. So we want to set r equals 2 plus cos theta equal to 5/2, which means cosine theta is going to be 5/2 minus 2, 1/2. And then cosine is 1/2 on the unit circle at pi/3 and negative pi/3. So this angle is pi/3. So we're going to do an integral from 0 to pi/3, and we're going to double it. So 0 to pi/3 finds this part, double it to get the whole thing. And this is going to be 1/2. We need our outer radius squared. Outer is on the limicon, 2 plus cos theta squared minus our inner squared. So our inner endpoint is here on the circle, 5/2. So minus 1/2 times 5/2 squared d theta. So, and actually you should be able to evaluate this integral. Let me give you a hint here. Multiply the 2 in, and then that'll cancel the 1/2 there. So now try and evaluate this integral. So pause the video and try and evaluate that integral, and then come back and look and see what I did. Alright, so you first should have FOILed out this 2 plus cosine squared. So 2 plus cosine gives 4 plus 4 cosine plus cosine squared. 5/2 squared, 25/4. Then combine your numerical terms, gives -9/4. This we know how to integrate. Cosine squared, we've got to trade out with half angle for 1/2, 1 plus cosine 2 theta. Multiply your 1/2 in. -9/4, +1/2 is -7/4. 4 cosine theta stays, and then 1/2 cosine 2 theta right there. Now we know how to integrate everything. -7/4 theta plus 4 sine theta plus 1/4 sine 2 theta. So notice we multiplied by 1/2 or divided by 2. And we're evaluating from 0 to pi over 3. 0 gives 0 all the way across. Pi over 3 be -7/4 pi over 3 plus 4 sine pi over 3. Sine pi over 3 is √3/2. Plus 1/4 sine 2 pi over 3. That is also √3/2 if you check your unit circle. So that gives -7 pi over 12 plus 4 times √3/2 plus 1/4 times √3/2, which is -7 pi over 12 plus 17/8 √3. So a lot of simplification going on afterwards. That, I mean, you could have just left like this for me. Not a big deal. So key idea here, though, when you've got an outer and inner radius, you may have to use the difference, or you want to use the difference formula to get your area. So with that example under your belt, you should be able to try WebAssign section 10.4, problem 3.